In this video, I'll be going over our study guide for Exam 2, which covers chapters 5, 6, and 7. So here's the list of vocabulary terms or concepts that you need to understand and know how to calculate or perform for chapter 5. And so the conceptual questions you'll see on the exam are very similar to the quizzes and practice exam, where you'll be presented a situation and you'll need to identify the appropriate distribution that applies. And then you'll also see quantitative problems that explicitly state which probability distribution applies so that you can use the appropriate formulas correctly. Let's go ahead and look at problem number 1. Based on past records, below is the discrete probability distribution describing the number of cars a Ford car salesman sells daily. Round all answers to 2 decimal places. So recall that discrete random variables are things that we can count. In this case, we're counting cars. And then you're also given the probability of obtaining this particular variable. So what's the chances that the salesman sells this many cars in a day? And then the table will walk you through how to solve the expected value, the variance, and standard deviation. This should feel very familiar to chapter 3. You did something similar. The main difference, though, is in chapter 5, we are now applying probabilities. So there's an extra step in this. What I recommend, while you can do this with a calculator, you can also use Excel. So what I've done is copy and pasted these values onto an Excel spreadsheet, and then I'm going to show you how to use Excel to solve it. So again, here's my X, or the cars sold per day, and then my P of X, or the probability of selling that many cars. And the first thing we're going to do is solve for the expected value. In other words, the average or the mean. To find the expected value, we're going to take our x's and multiply them by our P of X and then add them up. So the first thing we want to do is multiply our 6 by 0.2. So I'll type in equals, hit my 6, and then multiply that by our P of X of 0.2, and then hit enter. And that'll give me 1.2. And then if I click on that box, and in the lower right-hand corner where there's a little dot, if I carefully double click that, my formula will carry down to the remaining rows. And then what I need to do is add these numbers up. So you can type in equal sum and then select the values, or you can highlight them and then click the auto sum button. The auto sum button can be found on the far right, and it looks like a Greek letter E. So I'll click that, and so my expected value I got was the 8.2. The next thing we need to do, according to column D, is I'm going to take each of my X values, that's the cars sold, and minus the E of X. So what I'll do carefully is type in equals, click on the 6, minus, and then I'm going to type in the 8.2. This will avoid accidentally messing up my Excel formulas when I double click on the dot. Because if you click on this and don't freeze the cell, when you carry the formula down, what'll happen is the numbers will move down and it will subtract the blank cells down below. Then from there, I can go ahead and pick my cell and double click on the little dot, which will carry my formulas down. In column E, looks very similar to column D, except what we're doing is squaring the number. So we're going to take what we found in column D here and square it. So the easiest way to do that is to type in equals, choose the cell that you want to square, and then hold Shift 6, which will give you the little caret or little hat, and then type in 2 because we're squaring it. Again, I'll hit enter, and then I'll click on the cell and double click on the dots, and that'll bring my formula down. In column F, it continues on, so I still have this part here. I just finished squaring it. And what we need to do now is multiply it by the probability of X, our P of X. So this is where students often make a mistake because we'll multiply it by the wrong value. So you want to be really careful. We're multiplying it by the P of X. So carefully look which column has the P of X's. We can see that's column B right here. So I'll go ahead and hit equals. I'm going to click on the 4.84, which is the cell that represents this first part, and then do multiply, or the Shift 8, to get my little asterisks. And then my P of X, that's in column B. Remember, P of X, or the probability, always is in a decimal format because probabilities have to be between 0 and 1, as we learned in chapter 4, and then hit enter. And then clicking on that cell, again, you can double click on the dot here, or another way to do it is if you want to hold the dot and carefully drag it down and then let go. That also works as well. Excel lets you do it a couple different ways. Just find the way that works best for you. And then for the variance, we're going to add these numbers up. So I'll type it so you can see how that works. So I'll type in equals sum and then parentheses, and then choose the cells I want to add up, and then close parentheses and hit enter. So my variance is 1.96, but to get my standard deviation, we have to square root it. So I'll go ahead and type in equals square root with the parentheses, and then choose the 1.96. I can click on it or I can type 1.96, either way works, and then close parentheses and hit enter. So our standard deviation is 1.4. And so I've put the answers over into the study guide so you can see how you would fill it out on the exam. Let's go ahead and do problem number 2. USPS claims that no more than 9% of all packages arrive at the address late. Assuming the binomial probability distribution, if a sample size of n equals 30 packages is randomly selected, solve the following probabilities. So what you'll notice here is I've already pulled out the variables you need to pay attention to, and just like on the real exam, I do bold and underline all the components you need to pay attention to. So in this case, our P, or the probability of success, is 0.09, because that comes from the 9% of all packages, the probability of something coming late. The N, or our sample size, is the 30, that's given here for our 30 packages. And we are using the binomial probability distribution. So we're going to be using the equals binom.dist formulas. In part A, it says, what is the probability that exactly 2 packages will be late? So I've created an Excel file that you can use on the exam as well as on the study guide, and it has the chapters 5, 6, and 7 formulas. So you just have to make sure that you're on the correct tab. And I have labeled at the top as well, formulas from, and then the name of the chapter. So here we're working with binomial distribution. It's helpful to look at the notes here because I do remind you which formulas apply. To find exactly x, it is not cumulative, so you'll want to use the formula that has the false in it. So we're going to be using this first formula right here. So I'll type in equals binom.dist with the parentheses, and then the x, or the thing I'm interested in solving for, is the exactly 2 packages, comma, the n is my sample of 30 packages, comma, the probability of packages coming late was the 9%, or 0.09, and then I'm going to type in false because it's not cumulative. I'm not adding up probabilities. I just want to find the exact probability of 2 packages. And then hitting enter, I get 0.2513. So I'll go ahead and show the work right here as well. Let's go and do part B. What is the probability that 3 or less packages will be late? Looking at the notes at the bottom here, it does remind you, if you forget, to find X or fewer, like a less than scenario, it is cumulative. And knowing that Excel reads probabilities from left to right, we'll use the true and just use the formula as we see it. So we're going to use this formula right here. I'll type in equals binom.dist, and then the X that I want to include, because I want to know 3 or less, will be 3. The trials won't change, that's still n equals 30. The probability hasn't changed, that's still 9%, or 0.09. And it is cumulative because we are adding up the probabilities. We're adding up the probabilities of 3, 2, 1, or 0 packages coming in late. And then I'll hit enter, and we get 0.7175. Let's go ahead and look at part C. What is the probability that 5 or more packages will be late? So the note down here reminds us that to find X or greater, or like a more scenario, we'll take 1 minus the cumulative version of the formula. And note that since we're counting, we want to be careful about the X that we put in there. So here's the formula right here. I'll go ahead and type in equals 1 minus binom.dist. Now because Excel only reads left to right, meaning from 0 and up, but we're interested in 5 or more. So we want to know the right side. Since we want to know the probability of 5 or more packages, I need to get rid of what I don't care about. So we're going to subtract 4 or less. That's why for the X variable, I'm going to type in 4 because that's what's going to get subtracted from the curve. That's why the note here is saying X minus 1. We have to go down by 1 because we're counting. So we'll put 4 in here. Then for the trials, the N is still 30 and the probability is still 0.09 and it is cumulative. We're adding up the probabilities of 5 or more. So 5, 6, 7, 8, 9, 10, all the way up to 30 packages. So we'll make sure to type in true and then I'll hit enter. And we get 0.1277. Let's go ahead and do part D. What's the expected value, or the mean, in the sample of packages that are late. So I've got the formula here already on the left, and again, you can use Excel or a calculator, but we're just going to take our n of 30 and multiply it by our p of 0.09, and that will give us the 2.7 packages. In part E, we want to know the standard deviation in the sample of packages that are late. So again, the formula is given right here on the left. So you can do it with a calculator or with Excel, but if you're using Excel, you can use equals square root. So that's SQRT for square root with the parentheses, and then you'll multiply N, P, and Q. So our N is the 30 packages times P, which is the percentage of late packages at 0.09, times Q, which is the complement of P. So the formula for Q is 1 minus P. So I would do 1 minus 0.09 to get my Q, and that would give us 1.57 packages as the standard deviation. You can also do this mentally right here. You don't have to type it all out. If we know that P is the probability of late packages at 9%, Q is the complement or the probability of packages that are not late. So if I know 9% of packages are late, I know 91% of packages are not late. Let's go ahead and do problem number 3. Cars arrive to a bank ATM drive-thru according to a Poisson distribution with a mean of 4 cars per hour. So the way I structure my problems is to walk you step by step so that you don't rush to Excel and make an error. So follow the structure and you'll be okay. So in part A, what is the expected number of cars arriving in 2 hours, or lambda times t? So again, imagine if you're standing there at the bank ATM for 2 hours. How many cars would you expect to see? If I know that 4 cars come in 1 hour and I stand there for 2 hours, when I do lambda times t, or 4, which is my lambda, and t, which is 2 hours, the number of segments I'm standing there watching the ATM, that's going to be 8 cars. So I can do this mentally with a calculator or with Excel. 4 times 2 gave me the 8 cars that I would expect to see if I'm standing there watching the ATM. So in part B, we want to know what is the probability of 6 or less cars arriving in 2 hours. So you'll notice I have not changed the segments. I'm still standing at that ATM watching it for 2 hours. So going over to our Excel file, I do remind you that our mean in Excel is the lambda times t. So the mean that you found in part A. Since we're doing a less than scenario, 6 or less cars, we're just going to use the formula as is, but make sure that it says true in it because we are adding up variables. We're adding up the probability of 6, 5, 4, 3, 2, 1, or 0 cars arriving in the 2 hours that I'm standing at the ATM. So I'll go ahead and type in equals Poisson.dist parentheses. My x is going to be the 6 because it's 6 or less cars. So I want to include that 6. Excel reads from left to right. So if I put in the 6, that means Excel is going to read from 0 up and including the number 6, comma, our mean we found in part A, which is the 8 cars, comma, and then true. We'll go ahead and hit enter, and we get 0.3134. In part C, we want to know what is the probability of 9 or more cars arriving in 2 hours. You'll notice I have not changed the segment. We're still standing there looking at the same ATM for the 2 hours. So going over to Excel, this is a greater than scenario. Anytime we're doing greater than, it's 1 minus the formula. So I'll go ahead and type in 1 minus Poisson.dist. Now the x here, since I want to know 9 or more cars, meaning I want to start counting at 9, 10, 11, and up, I need to subtract or get rid of the left side, starting at 8 and below. So I'm going to use 8 as my x, because that's the left side of the curve that I need to subtract, because I only care about 9 or more cars. The mean is still the 8 that we found in part A. So 4 times 2 gave us that 8, and then type in true, because it is cumulative. We'll go ahead and hit enter, and we get 0.4075. So the common error that I notice in part C for Poisson is that when we get to the mean, our brain reverts back to the mean in the story of 4 cars. But remember, that 4 cars is only per hour. In part C, we're asking about a particular scenario, in this case, 2 hours. That's our segment. So we have to honor that lambda t that we found in part A. So if you have any questions on Chapter 5, just let me know.